Okay, so let's refresh our memory first thing about what we know about our reciprocals. We know we need our cream and sugar. So we know that the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. We also know SOHCAHTOA, and so we're going to use that information and kind of extend our thinking. If you recall, I have talked to you about the fact that a lot of trigonometry, we want to impose or transpose these triangles that we are drawing onto a coordinate plane. So if we were to draw a right triangle in our coordinate plane, we always draw them in a particular format where we're drawing so that we have one angle that is just near the origin and that we draw the right angle. And so another thing to get memorized, I would suggest flashcards for this. Another thing to get memorized is the fact that we're going to think about this right triangle now. So instead of talking about this, you might need to kind of think about this to begin with, but if you think about it, the way I've drawn this right triangle in reference to this particular angle here of theta, y corresponds to our opposite side, x corresponds to our adjacent side, and we're not going to call it the hypotenuse when we are talking about coordinate points and using this on the coordinate plane. We're going to refer to the hypotenuse as r, which is a radius. Now the radius will always be positive, but our x values and y values, if you think about it, x and y values could be positive or negative depending on what quadrant we're in. So keep that in mind as well. So this is what you're going to have to start to get memorized now. Using this particular triangle, if I wanted to think about how I could write this ratio for the sine, instead of using opposite and hypotenuse, if I use my x or y or r. So you will notice that for sine, we know it's opposite over hypotenuse, but then what that corresponds to in the coordinate plane is that that is the same thing as doing the y value over the radius. Obviously, what that means then for the cosecant is that we're going to do the radius over y. No, you don't need to memorize that, but you need to know that cosecant's the reciprocal of sine, so you can flip it. All right, so similarly, for cosine, we would go to the adjacent side, and that corresponds to the x-coordinate on a coordinate plane, and then adjacent over hypotenuse, so the hypotenuse is we're going to call the radius. We're going to think of this as, imagine basically like the radius of a circle. All right, and then for tangent, we do opposite over adjacent, only in this case with x's and y's and r's, that means it's going to be y over x. And I got so excited to get going that I forgot to mention, obviously for secant, we're going to flip and do r over x, and for tangent, we're going to do x over y. So something new to memorize. For the sine ratio, I want you to memorize that sine can be thought of as y over r, cosine is x over r, and tangent is y over x. And then as long as you still have these, get these memorized, you're not going to need to memorize this here. Okay, so sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x. So here's one situation where we use this information. So we're going to go back to our quadrantal angles. If you recall, we talked about quadrantal angles a little bit. With quadrantal angles, we can't really draw our triangle, right? If we have a quadrantal angle, then our angles are right on the axis. And so to try to draw a triangle, the triangle would basically collapse upon the axes. All right, but we do still have x values and y values. We have coordinates at these different points that we can use in order to come up with values. So I chose just a random, my favorite number is 7. That's my lucky number. So I chose 7 Guys, you could use any number you wanted here, whatever your favorite number is, your lucky number. If you wanted to write these and think about the fact that if we go out a particular distance, so in this case 7, and we can put a point here at 0 and 360 degrees, we can go up 7 so that we're at this point along the 90-degree angle mark at 0, 7, over here at the 180-degree mark at -7, 0, and then, ooh, that doesn't look like a 0, -7, and it should be. So let me fix this because I don't want you thinking something got erased there. That's a -7, 0, -7 for that coordinate point. So here's how we can use this information. So if we're asked to figure out what the sine of 90 degrees is, so we need to think about what the ratio is that we know up here for sine. So sine at 90 degrees. So sine, the ratio is y over r. So we want to go to 90 degrees and we want to pick out what the y value is, which is 7. And then the r value, the radius, the distance we're going out from our origin, which is 7. And so we get that the sine of 90 degrees is 1. Now what you're going to find is for quadrantal angles, these trig functions have kind of some very specific values that you're going to notice. There's going to be some repetition, but it's just to help you see this is kind of a special case. So the cosine of 180 degrees, that means we're going to go to 180 degrees at this particular coordinate point, and we want to look at the x value over the r. So we get -7 over 7, so -1. Next one, tangent of 270 degrees. Tangent is the ratio that we are going to memorize is y over x. Tangent is y over x. And so if you look at what the y value is over the x value, we get -7 over 0. Well, we know that's undefined. So far you've seen that for these quadrantal angles, some of our answers might be 1, they might be -1, they might be undefined. You're going to see one other possibility, but let's look at some more examples here. So for this one, we're doing the cosecant, which means we look at the sine. That's the reciprocal of sine. Sine is y over r. So cosecant, we're going to do r over y, and we're going to look at 0 degrees. So the r we know is 7, and our y value is 0. So once again, we get undefined. And then secant of 90 degrees. Secant is the reciprocal of cosine. And cosine we know is x over r. So now let's flip that and let's do r, which is 7, over x, which is 0. We get undefined again. And then cotangent of 180 degrees. If you notice, we go to our value, our coordinate point at 180 degrees, and we do x over y, so that's -7 over 0. So once again, one last time, I promise, it's all you're going to see of that, is you find that that value is undefined. All right, let's look at a few more examples here. Cosine of 90 degrees. For cosine, we're going to memorize that cosine is x over r. And at 90 degrees, if we do x over r, we're going to have 0 over 7, which is just equal to 0. So that's another value that you will see. So for all of these quadrantal angles, you will find that the answers are either 0, +1, -1, or undefined. So that's kind of a special case here with these quadrantal angles. For tangent of 180 degrees, tangent, we're going to do y over x. So we do 0 over -7, and we get 0. And lastly, the cosine. Cosine, we're going to memorize x over r. Cosine is x over r. We want to go to 360 degrees and look at the x coordinate and put that over the r, which is the 7, and so we get 1. We will do more practice with this, I promise. 2 more examples real quick. And this is going to help you see a little bit better how and why we're using this X and Y and R business. Okay, so if we wanted to draw a right triangle to represent this particular coordinate point of -9, 12, then think of our coordinate plane here, right? This is our coordinate plane, but -9, 12, that means we're going left 9 and up 12, and then we put our point there. So that's how we draw our triangle. Our angle that we're going to use as our reference is this angle right here. We need to figure out what R is equal to. We need to do Pythagorean theorem, or if you noticed, hopefully you did, this is a triple. This is really the same thing as a 3, oh goodness, come on, why is my pen doing this? This is a 3, wow, 4, 5, that's getting multiplied by 3. So that means this side is 15. And remember, the radius is always positive. Now, let's think about this. You've memorized, or at least you need to memorize, that the sine is the y value over the r. So if we're going to do y over r, that means we're doing 12 over 15, but we have that common factor that divides into each of these. So really it's 4 over 5, and that makes cosecant 5 over 4. For cosine, we're going to memorize that it's x over r, and if you look at what the x coordinate is, it's -9 over r, which is 15, and we can simplify that because we have that common factor, so we get -3 over 5. Now notice that's a negative sign now that we have to include. Our secant, we're just going to flip that answer, so we get -5 over 3. And then, here's the pretty part. I like tangents. You just have to remember that we're going to do y over x. So that gives us 12 over -9. And we can reduce that one more time. So we can think of this as 4 over -3. So our cotangent is -3 over 4. All right, so that's an example where we're actually truly using the triangle. This next example, if you notice, I've drawn in on the coordinate plane again. I'm going out a distance of 4, I'm going down a distance of -7, and then I'm going to create this right triangle. And we are going to have to figure out what our r is equal to. We've got to do Pythagorean theorem. So that would be 16 plus 49 is equal to r squared. We get that r squared is equal to 65. So r is the square root of 65. Now, here's the deal. For many of us, it's really helpful to see this triangle. But for some of you, it might be just as easy for you to just think about this and recognize this is my x, this is my y, here's my r, and you don't even really need to draw the triangle. And if that's the case for you, that's great. You do not need to. I'm going to draw it just because I'm such a visual person that I feel like it's helpful to see it. But also for those others of you who it makes sense to actually see it also. All right, so we are supposed to write these ratios for all of these trig functions. Sine, we're going to memorize as y over r. Sine is y over r. So we're going to look at the y coordinate over the r. And guess what? Yes, we're going to have to rationalize this. So it's not very pretty, but it's -7 root 65 over 65. But in order to write out our cosecant value, we're going to flip that. That's going to be much easier to deal with. So we're going to write that as -square root of 65 over 7. All right, cosine. The cosine ratio that we're going to memorize now is x over r. And so we're going to look at the x value, which is 4 over the square root of 65. Yes, we need to rationalize that. So 4 root 65 over 65. And once again, we are going to look at, this in order to flip it for our secant value. So square root of 65 over 4. And then last one, let's take a look. For tangent, we're going to memorize that that is y over x. And so we are looking at those two values. So negative 7 over 4. So our cotangent, when we flip it, is negative 4 over 7. And boom, we're done. Memorize, please do flashcards, whatever it takes to get memorized to those ratios. Sine ratio is y over r. The cosine ratio is x over r. Tangent ratio, y over x.